Close your eyes for a moment and imagine standing at the edge of something ancient. The air here is different, thick with moisture and alive with the whisper of countless leaves breathing in unison. This is the threshold of the rainforest, where the very atmosphere seems to pulse with an energy that has remained unchanged for millions of years. You are about to enter one of Earth's most extraordinary living systems, a place where every breath you take connects you to a network of life so intricate and vital that scientists have come to call these forests the lungs, heart, and brain of our planet. The comparison is not merely poetic. As you step beneath the emerald canopy, you become part of a respiratory system that spans continents. Every tree around you is engaged in the ancient dance of photosynthesis, drawing carbon dioxide from the air and releasing oxygen in return. But this is photosynthesis on a scale that staggers the imagination. The Amazon rainforest alone produces roughly 20% of the world's oxygen, while rainforests across the globe collectively process more carbon dioxide than any other terrestrial ecosystem. You are walking through Earth's breathing apparatus, feeling the gentle exchange of gases that has sustained life on our planet for eons. The morning mist clings to the forest floor around your feet, and you notice how the very air seems to shimmer with moisture. This is the forest's circulatory system at work, its heart pumping water through an invisible network that reaches far beyond these trees. Each leaf above you is a tiny pump, drawing water up from the soil through the tree's roots and releasing it as vapor through microscopic pores. A single large tree can transpire hundreds of gallons of water each day, sending moisture into the atmosphere that will eventually fall as rain hundreds or even thousands of miles away. The sound of your footsteps is muffled by layers of decomposing leaves, each one a page in an endless book of recycling and renewal. Beneath this soft carpet, an unseen universe thrives in the darkness. Fungi spread their thread-like networks through the soil, connecting root systems across vast distances and allowing trees to share nutrients and even communicate through chemical signals. This underground internet predates human civilization by hundreds of millions of years, yet it operates with a sophistication that we are only beginning to understand. As you walk deeper into the forest, the canopy above begins to reveal its secrets. Imagine climbing upward through the layers of this vertical world, each level supporting its own community of life. The forest floor, where you began, is the domain of decomposers and recyclers, where nutrients are constantly being broken down and reformed. Above, the understory filters the light into a gentle green-tinted glow, perfect for the shade-loving plants that carpet this level. Higher still, the canopy spreads like an ocean of leaves, home to countless species that may never touch the ground. It was in forests like these that early humans first learned to read the subtle signs of nature. Indigenous peoples developed an intimate knowledge of these ecosystems, understanding which plants could heal, which fruits were safe to eat, and how to move through the forest without disturbing its delicate balance. They recognized something that modern science is only now beginning to fully appreciate: that the rainforest functions as a single interconnected organism, where every element depends on every other element for survival. The trees around you are not merely growing toward the light, they are engaged in a constant conversation. When one tree is attacked by insects, it can release chemical signals that warn its neighbors to begin producing defensive compounds. When a tree falls, creating a gap in the canopy, nearby trees adjust their growth patterns to fill the space. This is the forest's brain at work, a network of communication and response that operates without any central control, yet maintains the health and stability of the entire system. As the day progresses and shafts of sunlight begin to penetrate the canopy, you witness one of nature's most remarkable phenomena. The forest is creating its own weather. The moisture transpired by the trees rises into the atmosphere, where it cools and condenses into clouds. These clouds will bring rain back to the forest, sustaining the very trees that created them. This is the forest's heart pumping life through its own circulatory system, a process so fundamental that disrupting it can change weather patterns across entire continents. Not far from where you stand, a butterfly alights on a flower, its wings catching the filtered sunlight. This simple act is part of a pollination network that spans the entire forest, connecting flowering plants across vast distances and ensuring the genetic diversity that keeps the ecosystem healthy. The butterfly's ancestors have been performing this same dance for millions of years, their roots and timing perfectly synchronized with the blooming cycles of countless plant species. Meanwhile, in another part of the world, scientists are making discoveries that reveal just how crucial these forests are to global climate stability. They have found that rainforests don't just respond to climate, they actively regulate it. The Amazon rainforest, for instance, generates much of its own rainfall through transpiration, creating a climate that can sustain itself even during dry periods. When large areas of rainforest are removed, the self-regulating system begins to break down, potentially triggering changes in weather patterns that can be felt thousands of miles away. The complexity of these relationships becomes even more apparent when you consider the forest's role in the global carbon cycle. The trees around you are not just producing oxygen. They are also storing vast amounts of carbon in their wood, roots, and in the soil beneath your feet. A single hectare of mature rainforest can store as much carbon as a small city produces in a year. This makes rainforests one of our planet's most important tools for regulating atmospheric carbon dioxide levels and maintaining climate stability. As you continue through the forest, you encounter evidence of the sophisticated ways in which different species have evolved to work together. Certain trees have developed relationships with specific types of ants, providing them with shelter and food in exchange for protection from herbivores. Fungi form partnerships with tree roots, exchanging nutrients for sugars in a trade relationship that has persisted for hundreds of millions of years. These are not random associations, but carefully evolved partnerships that benefit both parties and strengthen the entire ecosystem. The forest's role as Earth's brain becomes even more evident when you consider how it processes and stores information. The genetic diversity contained within these ecosystems represents millions of years of evolutionary experimentation and adaptation. Each species is a repository of solutions to environmental challenges, containing blueprints for medicines, materials, and technologies that we are only beginning to discover. The rosy periwinkle from Madagascar's rainforests gave us treatments for childhood leukemia. The Pacific yew tree provided us with a cancer-fighting compound. The secrets held in the genetic code of rainforest species may hold keys to solving some of humanity's greatest challenges. As the afternoon light filters through the canopy, creating ever-changing patterns on the forest floor, you begin to understand why the loss of these ecosystems is so concerning to scientists. When a rainforest is cleared, we lose not just the trees, but the entire network of relationships that has taken millions of years to develop. The underground fungal networks are destroyed, breaking the communication systems that connected trees across vast distances. The water cycle is disrupted, affecting rainfall patterns far beyond the deforested area. The carbon stored in trees and soil is released into the atmosphere, contributing to global climate change. Yet there is also hope in these forests. As you walk, you notice young trees growing where older ones have fallen, and you realize that the forest has a remarkable capacity for renewal when given the chance. Around the world, reforestation projects are working to restore damaged ecosystems, and indigenous communities are being recognized as the most effective guardians of these vital resources. Scientists are developing new technologies to monitor forest health and track changes in real time, giving us better tools to protect these precious ecosystems. The setting sun sends long rays through the forest, and you pause to reflect on what you have experienced. You have walked through Earth's respiratory system, felt the pulse of its circulatory network, and witnessed the operations of its most sophisticated information processing system. The rainforest is not just a collection of trees. It is a living entity that breathes, circulates nutrients and water, and processes information in ways that sustain life on a global scale. As you prepare to leave this remarkable place, you carry with you a deeper understanding of our planet's intricate systems. The air you breathe, the water you drink, and the climate that sustains human civilization all depend on the continued health of these extraordinary ecosystems. The rainforests are indeed the lungs, heart, and brain of our planet, and their preservation is not just an environmental concern, but a necessity for the continuation of life as we know it. The forest will continue its ancient work long after you have gone, breathing oxygen into the atmosphere, pumping moisture into the sky, and processing the endless flow of information that keeps our planet's systems in balance. In protecting these forests, we protect the very foundations of life itself, ensuring that future generations will be able to stand where you have stood and marvel at the quiet miracle of Earth's most vital organ still beating, still breathing, still thinking in the language of leaves and rain.